measures of center, spread, and position. Yeah. Now, the measures of center, the first I'm going to talk about is the mean. What is the mean? The mean is the same thing as calculating the average of a data set. And the mean is affected by outliers. So it might not always represent the typical value. And how do we calculate the mean? For example, you can have something like A, B, C, and D as your data set. I'm going to provide an example in the subsequent slide. Then to calculate the mean, it means you have to add up the data set and divide it by the number of observation you have, which is going to be 1, 2, 3, 4. So this is the general method for calculating the mean. Secondly, we have the median. The median is the middle value in a sorted data set. So the first thing you have to do before you use the median is to sort your data set. It can be in decreasing order or in an increasing order. For example, you can have A, B, C, D, E. Then you look for the middle value, which is going to be C, and this is going to be your median. But in some cases, you can have it as even numbers or you can have it as odd numbers. In this case, we are having this as odd numbers, which is 1, 2, 3, 4, 5. But in the case where you have it in form of middle number, like example, you have A, B, C, D, E, F. In this case, you are having these two numbers in the middle. So what you have to do is to calculate the average. In the subsequent example, you will see how this is being done. And the last one is called the mode. Another name for mode is the most occurrence, the most frequent value in a data set. That is the mode. If you look at these three measures of center, the median is not being affected by the extreme values. And here we talk about comparing the mean and the median. This can be used to define the shape of the distribution. Anytime your mean is greater than the median, then you can confidently say that your data set is skewed to the right. In the previous class, we talked about skewness to the right, skew to the left, and symmetric. When your mean is greater than the median, then you can say that the data is skewed to the right. If the value of the mean is less than the median, then you can say that the data is skewed to the left. And lastly, anytime your mean is approximately the same thing as the median, then we can say that this is symmetric. In the subsequent example, I will give you some data sets and I will ask you to find the shape of the distribution.
Switch to Google Fi Wireless. With features like hotspot tethering and spam call blocking included, plus 5G coverage nationwide. Get a simple, secure phone plan by Google that's right for you and your budget. Try Google Fi Wireless today.
Also, we talk about the measures of spread. Here, when you talk about the word spread, we are interested in talking about the variation. And here we talk about the range, the standard deviation, and also the variance. When we talk about the word range, range is the difference between the minimum and the maximum value. So range, the formula for range is the max value minus the minimum value. This is the formula for calculating the range. And also we have the standard deviation. In our next video, I'm going to give you an example on standard deviation. Easily, this can be done using the TI-83 or 84 calculator. Now we have this example. The cost price of the products for 10 randomly chosen days is reported as given. If you look at the data set is already sorted, which is in ascending order. Now the question is find the mean. And to find the mean, we have several notations to find the mean. The mean can be represented as x bar, which is the same thing as saying 1 over n summation of your xi, where your I is from 1 to n. And in this case, it means the addition of everything you have, which is 24 plus 25 plus 29 up to the last value, which is 40, dividing this by the number of data sets, which is 10. If you sum up the numerator, you should have 3317 over 10, which is the same thing as 31.7. The next one is find the median. Now, to find the median in this case, we need the middle value. And if you look at this data set, we have even numbers, which is 10. So the two middle values are going to be, okay, the 5th and the 6th value. Or alternatively, you can do it this way. Cancel out the first one, then you cancel out this. You cancel out the second one, and you cancel from behind too. You cancel out this, you cancel out this. You cancel out 29 and 35, then you can get the two middle values. And the median are going to be the average of those values, which is 30 plus 32 divided by 2, which is 62 over 2, and that gives 31. The next is to find the mode. Now, to find the mode, from the definition of the mode, it means the most occurrence. Looking at this, 29 appeared twice and 35 appeared twice. Other values appeared once. So the mode are going to be 29 and 35. And from the previous video I did, I told you when you have two modes, this is the same thing as bimodal. The fourth one is to find the range. From the definition of the range, which is the same thing as the maximum value minus the minimum value. So here, the maximum value is 40, the minimum value is 24. So the range of the distribution is going to be 16. And the last question is, what is the shape of the distribution? Looking at this, my mean is 31.7, and it is greater than the median, which is 31. If they are approximately the same, then it can be symmetric. But if you approximate this is approximately 32, which is greater than 31. Then I can say that this is slightly skewed to the right. To the right. So this is slightly skewed to the right. And here, in the next slide, we have that. Yeah, the next is the measures of position. Here, I'm going to be talking about the z-score. The purpose of the z-score is to tell us how many standard deviation data point is from the mean. So in the next video, I'll be talking more about the z-score. But here, we have the quartiles and the interquartile range. The IQR stands for the interquartile range. So the quartiles divide the data into 4 equal parts. Here we have the lower quartile, we have the upper quartile, and we have the median. So those are the things we have. So the median is dividing the entire data set into 2. The lower quartile divide the half of the data into 2, while the upper quartile divide the other half, the upper half of the data into 2. And here we have an example to show how to calculate the quartiles. Now, looking at this data set, the first we want to do is to find the first and the third quartile. Now, to do this, the first thing to do is to rearrange the data set. Yes, this is the first thing to do, because before you work with the quartiles, you need to rearrange the data set. And by rearranging the data set from the minimum to the maximum, we're going to have, we have 5, 6, 5, 6, 6, 7, 7, another 7, and we have 8, 8, 9, 9, 10, 10, another 10, and we have 11, 12, 12, 13, 14, another 14, 15, and then here we have 16, 17, 18, 19, and lastly we have 27. So the question is, find the first and the third quartile. Now, for the first quartile, to do that, you have to divide the data set into 2. Everything is 25. You divide the data set into 2, leaving out the median. So if you do that, the median is this 10. This is the median. You leave out the median. So you divide the data set into 2. This is the first half. This is 12 in total. And you have the other half of the data, which is from 11 down to 27. This is the other half of the data. Now, to get the first quartile, it means you find the median of this. And the median of this is going to be 7 and 8. These are the middle number, because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is half. Half of 12 is the 6th value and the 7th value. So if you take the average of that, this should be 7 plus 8 over 2, which is 7.5. So the first quartile is represented as Q1. This is the same thing as the first quartile, equals 7.5. Secondly, we have the third quartile is represented as Q3. So you look at the other half of the data. What is the middle value? It's going to be the 6th and the 7th value, which is 1, 2, 3, 4, 5, 6, 7. These are the middle values. And the half of this, if you take the average of this, is 14 plus 15 over 2, which gives 14.5. So this should be 14.5. So now we've gotten the Q1, we've gotten the Q3. And the next question is the interquartile range. The interquartile range is represented as high QR. And the formula is Q3 minus Q1, which is the same thing as 14.5 minus 7.5. And that gives 7.
Downy Unstoppables has odor blocker and keeps you fresh all day. Smell unstoppable. No matter what kind of teeth you gotta brush, Oral-B Electric cleans better with one simple touch. Oral-B's dentist-inspired round brush head hugs them, cleans them, and gets in between them for 100%.
Next, find the lower and upper outlier boundaries. I think these questions was repeated twice. Find the lower and the upper outlier boundary. For the lower outlier boundary, I'm going to use LOB. The formula is Q1 minus 1.5 IQR. And this is Q1, which is 7.5, minus 1.5, multiplied by the interquartile range, which is 7. So this gives negative 3. And for the upper outlier boundary, I'm going to use UOB, upper outlier boundary. The formula is Q3 plus 1.5 multiplied by the interquartile range. And Q3 is 14.5 plus 1.5 multiplied by 7. And this gives 25. So the lower outlier boundary is negative 3 and the upper outlier boundary is 27. The last question is, list all the values that are classified as outliers or extreme values. You see, the outlier are values above the LOB. So the values above the UOB or values below the LOB. Now, for the LOB, do we have any value below it from the data set? Do we have any negative values? If you check this, no. There's no value less than negative 3. And for the UOB, do we have any values? This should be 25. Do we have any values greater than 25? Yes. And what is the value? We have 27 to be greater. So the outlier is going to be 27. And choosing the right measure. For your data type, we have different measures are appropriate. It can be continuous or categorical. And for the data distribution, skewness and outliers can influence the choice of measure. And lastly, for research question, which is going to be done in the subsequent videos, the specific questions you are trying to answer will guide your selection of measures. Thank you very much for watching. See you in the next video.
With Robinhood Gold, earn with high-yield cash, plus get a match on IRA contributions, so you can make the most of your money. Sign up today for 30 days free.
Hello viewers, welcome back. Today, we'll be moving straight to episode 2 of our series on experimental... Welcome back. Today, we'll be moving to the episode 2 of our series on elementary statistics. Today, we're going to be talking about data visualization, a journey through graphical summaries. My name is Ajadi Nuruddin. Now, the first thing we'll be talking about is the qualitative data. And here, I'll be talking about the frequency distribution. What is the purpose of the frequency distribution? The main purpose is to organize data into categories and count occurrences. For example, we talk about the gender. For the gender, we have the male and we have the female. These are the categories. So, how to organize the data into these categories? This is the major purpose of the frequency distribution. And then when we talk about the frequency distribution, these display categories with their frequencies. For example, how many female students do we have in the class? How many male students do we have in the class? Okay, so these are categories. And secondly, we talk about the relative frequency. What is the difference between frequency and relative frequency? For relative frequency, we're talking about proportion of total data values in each category. I'm going to show you how this works out in the next slide. And there are some key notes we need to pay attention to. Is that for frequency, the total frequency must be the same with the sample size we have. If the sample size is 36, the sum of the frequencies must be the same thing as 36. That is about the frequency. And about the relative frequency, the sum of our relative frequency must be equals to 1 or 100%. So when you sum it up and you are not getting 1 or 100, then there's a mistake somewhere. Now we have this example. This example is about ice cream sales by flavor in a month. So we have 4 types of flavors. We have the vanilla. I know a lot of people love vanilla. We have the chocolate, we have the strawberry, and we have the mint chocolate. So these are the sales for each of the flavor. Our objective is to calculate the relative frequency. Now, if you look at this example, the sales here, this represents the frequency for each of the categories. So the sale represents the frequency. And like what I said, for frequency, the sum must be the same thing as the sample value. So when you find the sum of these, 120 plus 85 plus 50 plus 45, this is going to give us 300. This is the sum of the frequency. Then how do we calculate the relative frequency? To calculate the relative frequency, you need the frequency for each of the category divided by the sample size. Now, to get the relative frequency for vanilla, we have the frequency, which is what? 120 divided by 300. And this is going to give us what? 0.4. And in percentage, you can say that this is the same thing as 40%. Now, doing the same thing for chocolate, we have 85 as the frequency for the category divided by the total of 300. This gives 0.28, and this is equivalent to 28%. Doing the same thing for strawberry, we have this to be 50 divided by 300 equal 0.17, which is the same thing as 17%. And for the last, which is the mint chocolate, we have 45 divided by 300 equal 0.15, which is the same thing as 15%. And the rule for relative frequency is that the sum of the frequencies must be equals to 1. If you add this up, or what? If you add up the percentage, this should be the same thing as 100%. So this is how to calculate relative frequency. Number 2. Number 2. We have surveys on hours spent studying in a week by 20 students. So we have the data value given to us. And our objective is to construct the relative frequency distribution. Okay? This is our objective. Now, to do this, we have the study hours given. We need a frequency. Unlike the previous example, the frequency has been given to us. But in this example, we don't have the frequency. Now, to get the frequency, we have the study hour of 5. Now, let's strike out everywhere we see 5. Here we can see 5. This is 1. This is 2. You will have to be very careful so that you don't miss out on a value. This is 3. Now, looking at this, 5 comes up 3 times. Now, let's move to 6. How many times do we have 6? We have 1. We have 2. We have 3. And we have 4. So this shows that the frequency for 6 is 4. What about 7? 7 we have 1. 7 we have 2, and here we have 3. And let's move to 8. So we have 1, and we have 2, and we have 3. The purpose of striking out is for you to be able to identify the one already counted. And now we move to 9. How many 9s do we have? We have 1, we have 2. So 9 comes up 2 times. What about 10? For 10, we have 1, we have 2, we have 3. 10 comes up 3 times. What about 11? 11 just only once. What about 12? 12 just only once. So this is the total of what we have. If you add this up, you should get 20. Then how do we get the relative frequency? Using the same method, the same approach. Here we have 3 divided by 20. This should give 0.15. Here we have 4 divided by 20. Here we have 0.20. Here we have 3 divided by 20, 0.15. 3 divided by 20, 0.15. 2 divided by 20, 0.10. 3 divided by 20, 0.15. 1 divided by 20, 0.05. And 1 divided by 20 gives 0.05. If you add up this should be equivalent to 1. So this is how to solve the relative frequency. Now we move straight to visualizing the qualitative data. How do we visualize our qualitative data? First thing, we talk about the bar graphs, and also we talk about the pie chart and the Pareto. Under the bar graph, it can be classified as bar charts and histogram. And also under the bar chart, we have single bar chart, multiple bar chart. Okay, but everything is going to be under the bar graphs. In bar graphs, a bar graph looks like this. Okay, we use bars of equal width to display frequency or relative frequency. And this can be vertical or horizontal. So this is what a bar graph looks like. And secondly, we have a pie chart. It's in form of a pie. Or it's in form of a pizza. Let's put it that way. Now, this represents relative frequency as sectors of a circle, useful for showing part of whole. So this is what it looks like. Okay, we have something like this. And lastly, we have a Pareto. So this category is ordered by decreasing frequency, highlight the most significant categories. That is one thing about Pareto. And here we talk about quantitative data. In the previous example, we've talked about the qualitative data. It's in form of a group data. And here, I want to talk about a quantitative, which is going to be in form of a grouped data. Now, there are some steps we need to follow. For you to construct the frequency distribution, the first thing we have to do is to determine the number of classes. I'm ready to go again.
Bob DePio.
That's what I'm talking about.
Yeah, exactly.
Yes.
That works.
The best thing about it is, I know you didn't know when I popped it, but it was about 15.
And then you were ready?
15 minutes, I was ready.
What we have to do is to determine the number of classes. In this example, you can have a wide range of values, like 1 to 100. It's going to be difficult to list out 1 to 100 and start finding the frequencies. So what we do here is to use classes. Okay, this is the difference between this method and the previous one we did, because In the previous example we did, let me just go back. If you look at the study hours, we have from 5 to 12, which is very easy for me to get the frequencies. But in situation whereby we have large values, it's going to be a little bit difficult. So we use classes. Now, for classes, for example, let's assume we have 1 to 5, 6 to 10, 11 to 15, and 16 to 20. These are classes. In this case, we have the number of classes here. We have it to be 4 classes. 1, 2, 3, 4. Now, you have to determine the number of classes you want to use. Secondly, you calculate the class width. How do you calculate the class width? You check. There are some methods used in calculating class width, but the easiest method is 1, 2, 3, 4, 5. 1 to 5, 6 to 10. The difference between these, the width is 5, 5. 6 to 10, 11 to 15, 16 to 20, they are 5 values. So here, the class width are the 1 to 5, the 6 to 10, the 11 to 15. So what is the class width? Here we have it to be what? 5. If you look at the width, it is 5. Okay. Now, we set the lower limit. These are the lower limits, while these are the upper limits. Okay, 1 is the lower limit, 5 is the upper limit. And lastly, we tally the frequencies and calculate the relative frequency. But there are some key notes. Every value must fit into one class. You have to take note of that. There must not be any value without a class. Secondly, class should have consistent width. In this example, I'm using width of 5. And lastly, the total frequencies and the relative frequencies must sum correctly. This is very important. Now, we have this example. Now, in this example, we have the random sample of work durations in minutes by gym members. So we have 40, 45. These are the values. Now, we want to use 6 classes to construct the frequency distribution. And the classes has been given to us here. Now, how do we get the frequencies? To get the frequency, for the first class, 40 to 45. So you need the frequency for all the values that fall within the range. Let's go. From 40 to 45. Here we have 40, which is 1, 2, 3, 4, 5, 6, 7. So the frequency is 7. For the second one, we have for the next one, we have from 46 to 51. Now let's count from 46 to 51. Here we have from 46 to 51. We have 1. We have 2. Here we have 3. Here we have 4, 5. So we have 5. From 52 to 57. From 52 to 57. Here we have 1, 2, 3, 4, 5, 6. So here we have 6. 58 to 63. We have 1, 2, 3, 4, 5. 64 to 69. 64 to 69. 1, 2, 3. And 70 to 75, we have 1, 2, 3, 4. So for the relative frequency, using the same method, if you find the sum of these, the sum should be 30. And for the relative frequency, we have 7 over 30. This gives 0.233. 5 over 30, which is 0.167. 6 over 30, 0.200. 5 over 30, 0.167. 3 over 30, 0.100. 4 over 30, 0.133. So this is what we have as the relative frequency. If you sum this up, it's going to be 1. So this is for grouped data.
Your future is at your fingertips. Take advantage of the flexibility and diversity of futures trading with Ninja.
So this is for grouped data. And here we talk about the histogram visualizing the quantitative data. Just the same approach. The first thing we have to do is to get the data collection. Your data can be on anything. It can be on work, duration, or anything. Secondly, you create the frequency distribution. This is done by organizing your data into classes. And thirdly, construct the histogram. And lastly, analyze the shape. How do we analyze the shape? After histogram have been constructed, how do you analyze the shape? In this previous example, here, you can use the frequency or the relative frequency to construct the histogram. On this horizontal side, you can have the frequency, and also you can have the relative frequency. And here you can have your variable, your data values on the horizontal side. So this can be plotted using a concise and the same scale. Now, looking at your histogram, now you can use your Excel or anything, whatever, to draw your histogram. In fact, you can use your TI-84 or TI-83, which we are going to be using in subsequent classes to draw your histogram. Let's talk about the shape of the histogram. If your histogram is bell-shaped like this, bell shape, this is called symmetric. This is called symmetric. Why? Because both sides are mirror images, common in normal distribution. And I want you to pay attention to this very well. For a bell shape, this follows normal distribution. We're going to be talking about this in subsequent episode. This follows a normal distribution. And if you look at the second shape, this is called skewed to the left. Why? The easiest way you can get this is you can see it coming down. So the tail extends to the left, also called negatively skewed. So the scale extends to the left, just like in form of decreasing. This is called skewed to the left. And if you look at the last one, this is to the right. This is to the right. This is to the right. This is called skewed to the right. Or even this is skewed to the right. From this down here. Or you can even say this is going up and this is coming down. Either way. But if the tail extends to the right, we say skewed to the right. If the tail extends to the left, skewed to the left. To the right, skewed to the right. This is the easiest way for you to understand the two. So any histogram you've seen, it's easy for you to say, oh, what does this mean? And also, when it is symmetric, it means the mean is the same thing as the median. So we have it skewed to the left and skewed to the right. And the next thing we have here is stem and leaf plots. For the stem and leaf plot, this is another way to visualize your data. and it's very easy and straightforward. How do we do the stem and leaf plots? Number one, we separate the data into stems and leaves. The stem and leaf, just like you have a tree. We have the stem, we have the branch, we have the root, we have the leaves. So here we call it the stem and the leaf. Secondly, we order the leaves. It can be in ascending or descending order, but I prefer ascending. Number three, you include a key. Now, let's use this example below. Just on the workout durations in minute by 30 gym members, we want to use this to construct the stem and leaf plots. Now, this is the key. If you have 40, your 4 is going to be the stem, and the 0 is going to be the what? The leaf. So the units will always be the leaf. Now, let's look at this. Here we have 4. So for 4, we have 40, we have 45, here we have 40, here we have 45, and here, let's look at where we have 4, 40, and here we have 45. So what is going to be the leaf? Now, the leaf here is going to be, look at this, we have 40, we have 0, and here we have another 40, we have another we have 0, yeah. And here we have, you don't need to repeat. So here we have 0, 0, 0, 5, 5, 5. So this means we have 40 3 times and we have 45 4 times. Okay, and then if you look at 50, here we have 50 5 times. 1, 2, 3, 4, 5. Also we have 55 6 times. 1, 2, 3, 4, 5, 6. Coming to 60, we have 65 times. You can check it because of time. 1, 2, 3, 4, 5, and 65 3 times. 1, 2, 3. And for 70, we have 73 times, and we have 75 1 time. So this is how the stem and leaf plot works. And also we can have the back-to-back stem and leaf plot. For back-to-back stem and leaf plot, this is just following the same method. You need to identify the 2 data sets. You create separate stems. You add a leaf to both sides. You include clear labels and you analyze. So most times it always look like this. Here you have the stem.
Need to run Windows on your Mac? Parallels Desktop makes it simple to integrate Windows apps into your macOS workflow. Install Windows in minutes and stay productive without hassle. Run the apps you need when you need.
You have the stem. You have the leaf. And on this side too, you have the leaf. So they can have the same stem, but the leaf can be different. So this is how it works. And lastly, you have to avoid the misleading graphs. Yes. The first thing we have to note is that when you are drawing a graph, the proper labeling is very important. You ensure the horizontal and the vertical axes are clearly labeled and scaled appropriately. Most times, this can be the frequency, or in another case, it can be the relative frequency. Okay, and this can be your data values. It can be A in classification B, C, D, E. So you have to label it accordingly. And there's something we call area principle. That is, if you look, the proportion in graphs should accurately reflect the data they represent. When the data value is very small, then this shows that this is smaller than this. This can be 15 and this can be 20. So it should reflect what the data truly represent. And also we have the consistent scaling. So there should not be distortion in the data set, and the contextual information needs to be provided. At the end of this class, I believe you've been able to learn how to choose appropriate graphs, okay, for the qualitative and the quantitative, and the accurate construction. The most important part of this class is how to interpret the graph when we have it skewed to the left, skewed to the right, and symmetric. This is very important. Thank you very much for watching. See you next time. Bye.
With Robinhood Gold, earn with high-yield cash, plus get a match on IRA contributions.
Viewers, today I will be introducing you to the basic statistics. Our course is elementary statistics. So in our first episode, we're going to be talking about sampling, data, and experiment. My name is Ajadi Nuruddin. Now, I'm going to start with the basic definition of statistics. Statistics is the study of procedure for collecting, describing, and drawing conclusions from information. And in statistics, we have two things that we need to talk about. The first is the population, and the second is the sample. What is a population? A population includes all individuals under consideration, while a sample is the subset of the population. For example, when we talk about all the students of the University of Louisiana, that is our area of interest, then that's going to be the population. But when I'm talking about students doing elementary statistics, those are the subset from the entire population of students. Okay, that is a sample. Now, we have the parameter and statistic. Anytime I'm talking about parameter, I'm referring to population. And anytime I'm talking about statistic, I'm talking about a sample. So a parameter describes a population characteristic, while a statistic, look at this, does not have S. A statistic describes a sample characteristic. Now, here we talk about method of sampling. When you need to get information from people, there are several ways in which you can get your samples. And the first one is called a simple random sample. This deals with each collection of n population items is equally likely to be selected. In simple random sampling, which is called SRS, this is when your sample is being collected randomly. It does not have a fixed way of getting the information. For example, when you throw a die, okay, you can't predict the outcome of the die. This is randomly done. The outcome is going to be randomly done, okay? And one good thing about the simple random sampling is that it eliminates bias. So that's one good thing about it. And also, secondly, we have the stratified sampling. In stratified sampling, the entire population is divided into groups, and the groups are called the strata before random sampling from each. Now, let me give an example on this. When we talk about stratified sampling, okay, we have all the students offering elementary statistics in the university. We have like 20 sections of students offering elementary statistics, and each of the sections we have nothing less than 35 students. Okay, now all the students offering elementary statistics are called the population, for example. Now each of the sections are going to be the strata. So what we have to do is that get the list of all the students in each section, which are the strata. Then any students selected from each of the sections are going to be what? Are the sample we needed. Okay. You break down the population into strata, and from each of the strata, you select randomly from each. Stratified sampling looks similar to cluster sampling, but we have some differences. In cluster sampling, the items are drawn from the population in groups or in clusters too. Okay, the items are drawn in groups or in clusters. And lastly, we have the systematic sampling. Systematic sampling, the population items are ordered and samples are taken at regular intervals. In systematic sampling, it's like you going to Walmart and you have a line of people waiting for a bus. Okay, let me put that as an example. You have a line of 100 students waiting on a line for a bus. So in a systematic sampling, you can be like, okay, at every 10th student, those are going to be your sample. So in 100, so you count number 1 to 10, you pick that, that's going to be your first sample. From 11 to 20, you pick that, that's going to be your second sample. So at every 10-10 interval, each sample selected is going to form your sample space, okay?
Hey, Ryan Reynolds here for Mint Mobile with a very exciting announcement for parents everywhere. It's called Mint Kids.
It's a full-size plan for your mini-me.
I don't like that. See, this is the kind of stuff that I don't want my kids seeing online.
Upsy?
No.
Each sample selected is going to form your sample space, okay? That's what we call systematic sampling. Now, after we've learned about different ways of selecting samples, then what is data itself? Don't forget the word data is the plural form and the singular form is datum, D-A-T-U-M. So we have two types of data. The first one, we have the qualitative, also called the categorical variables, okay? And the second one, we have the quantitative, also called the what? The numerical variables. Now, what is the qualitative? In qualitative, from the word qualitative, we have it to be categorical. One, it describes the quality or categories of something. Example, when we talk about gender, gender is categorical. In gender, we have male, we have female. Okay? When we talk about color, we have white, we have black, we have red, we have indigo, so many colors. When we talk about type of car, we have the Mercedes, we have the BMW, we have the Toyota, so many types of cars. So these are categorical variables. So those are the qualitative variables. And then under the subtype, we have the ordinal and the nominal. Okay, the ordinal variables is variables that are in order. For example, when we talk about the grade in class, we have A, B, C, D, E. Okay, so those are what? Those are qualitative. And the easiest way for you to identify the difference between the two is that when we talk about qualitative, it does not involve numerical value. Yes. So they are always categorical. Now, but when we talk about the quantitative variables, this represents measurements or counts. When we talk about like the height, you're talking about the weight, the number of siblings. If you need information about the weight, you know that that's going to be a numerical variable. The number of siblings, the number of cars, the number of houses, those are numerical variables. And then under the subtype, we have the discrete and continuous. The discrete and the continuous. Now, before I move to the design of experiment, let me explain what is discrete, what is continuous. When we talk about the discrete variable, these are the kind of, the values that can be counted, something that you can count. Discrete, number of cars is countable. Number of houses is countable. The number of shoes is countable. The number of students in this class, they are countable. Okay? Those are discrete variable. But when we talk about continuous variable, these are measurements. For example, when we talk about the height, when we talk about the weight, these are measurements. Okay? And this involves a measuring tool. to take. So that is the difference between the discrete and the continuous. Now, we have the design of experiment. Explain what the experimental unit is. Now, looking at the picture on the left side, you can see two flowers. One of the flower is dry while the other one looks so radiant. Now, what is the experimental unit? The individuals or subjects being studied in an experiment. Now, looking at this, the flower itself is going to be the experimental unit. And the treatment is going to be the procedures applied to the subject to determine the effect on outcome. In this case, the treatment is going to be the fertilizers being applied. You can see that the first flower has the application of fertilizer, and the second flower does not have the application of fertilizer. And this is what the design of experiment is, because in the design of experiment, this is a very big topic in statistics. Okay, I'm not going to move deeply into that. Now we have the outcome. The variable being observed or measured in the study is the outcome. What do you observe at the end of the day? That's going to be an outcome. And lastly, we have the randomized experiment. Treatment are assigned to experimental unit at random. This is randomized experiment. And the types of study, the first one we have the randomized experiment. As explained, the treatment are assigned randomly. Large outcome differences indicate treatment effect. To have a better understanding of this, then we're going to be talking about the analysis of variance, ANOVA, and some other related topics. But the objective of this class is just to let you know the basic definition we're going to be using, in the future of this class. And second, we have the observational studies. The investigator observes individuals without modifying them. The only job of the investigator is just to observe and make some inferences from the observation, but no modification is going to be done. And lastly, we have the confounding variables, factors that can affect results without being part of the study design. For example, you have a flower and you have a pest affecting the growth of the flower. So this is one of the confounding, although there are some other real-life application of it, okay? And the last part of it is going to be the bias in studies. This area is one of the prominent areas in statistics where people spend a lot of time researching on. For a good statistical experiment, one of our objectives is that it must be free from bias. Yes, it must be unbiased. But there are some cases whereby you have some bias in studies. For example, let's have a look at these 4 bias in studies. The first one is called a voluntary response bias. When we talk about a voluntary response bias, results from individuals choosing to participate, often attracting extreme opinions. The voluntary response bias, for example, you have questionnaire, you have some online surveys being done. So this is example of voluntary response bias. An example is you buying something from Amazon, and after a week, you get a mail asking you to fill in some surveys. So this is voluntary. It's not compulsory for you to fill in the surveys. But the response you're going to provide is going to be based on what you feel like. Now, another instance is this: as a statistics teacher or professor teaching a course, at the end of the semester, you're going to get a survey to assess the class. A student that have an A in this course will probably give a good review, while students that have F will give a bad review. And a student giving a bad review might not truly reflect the competency of the professor, but due to the fact that the student have an F, so he or she is going to feel bad and feel like giving a bad review. The same thing the student that have an A, which will be prompted to give a good review. So this is voluntary response bias. Secondly, we have the self-interest bias. This occurs when study conductors have something to gain from the result. And this is not allowed in statistics because in this case, some of the people that conduct the experiment can manipulate the result to their own taste. And this is a big error in statistics. And the third one is social acceptability bias. This is something that is very common too. Like respondent provides answer they believe are more socially acceptable. In a situation whereby you are asking a respondent, whereby the respondent knows, we have different people with different culture. So there are some culture or some areas whereby women don't do a particular job. Now, when you're asking people in that region, they're going to give you something that they know that is socially acceptable to them. And in the real sense, this can be wrong. So it's going to lead to bias in the study. And the last one is the leading question bias. Questions are phrased to influence responses in a specific direction. This is commonly used by the security operative to get information out from the respondent or from the alleged criminal. So these are all bias in statistics. The key takeaways from this class is that I believe that you are able to understand the sampling method that we have. You will be able to identify the data types, the qualitative, the quantitative, the design effective experiment, and lastly, recognize and how to avoid bias. In our next class, we're going to move to another topic in statistics, and we're going to talk about some basic calculation involving this topic. And the major requirement for this class is going to be the TI-84 calculator or TI-83 calculator. And in my class, I'm going to be showing you how to